Okay class, today we are going to be talking about right triangle trigonometry, and we're going to be learning about something called SOHCAHTOA. Okay, so SOHCAHTOA, the S is for sine, the O is for the opposite side of your angle, and H is for your hypotenuse. So for example, if you have your angle here, which is called theta, so if you want to find sine of theta, you look at the opposite side and the hypotenuse, and you take the ratio. So if you wanted to find sine of this angle, we're going to look at the opposite side, so the one opposite, and we're going to put that over the hypotenuse here. So we have for a right triangle, and we have an angle theta. We have an opposite side, we have a hypotenuse, which is opposite the right triangle, and we have an adjacent side adjacent to the angle theta. Okay, so this works for right triangles only, and in this unit we're only going to be dealing with right triangles, so I apologize if I don't put the right triangle markings in. So this SOHCAHTOA will work for all right triangles, and this entire unit will be right triangles. Okay, so we talked about the SO. Then you have CAH, C-A-H, which is for cosine of an angle, is the adjacent side over the hypotenuse. And then finally TOA, which would be tangent, is the opposite over adjacent side. So these are the three main trig functions that we're going to be using, and we are going to need an angle for all of those. The angle is either going to be called theta, or it's going to be a number like 30 degrees. Okay, so everything that we did with those special right triangles, the 30, 60, 90, and the 45, 45, 90 triangle, we can find sine, cosine, and tangent of all of those special angles. Then we have what's called the reciprocal trig functions. And they are, well, just reciprocals. So this next one is called cosecant. Okay, we say cosecant, we write CSE. Cosecant is the reciprocal of sine. If sine is opposite over hypotenuse, the reciprocal is hypotenuse over opposite. Okay, then we have secant, which is the reciprocal of cosine, and secant of an angle theta is hypotenuse over adjacent, because cosine was adjacent over hypotenuse. And the last one was cotangent. We don't say cot in ksk and sick. It's cotangent. And cotangent is adjacent over opposite. It's the reciprocal of tangent. Okay, so for the reciprocals, the sine goes with the cosecant, cosine goes with secant, and tangent goes with cotangent. And they're just reciprocals. You just flip those. So if you remember SOHCAHTOA, and you remember which ones get matched up, then you should be able to remember the ratios. So at some point we will get to the point where you have to memorize all of these trig functions. Okay, so we're going to do examples of where we would use these things. So here we're given a right triangle, and we're given an angle theta, and you're going to use the triangle to find the exact value of cosine of theta. So here's our angle theta. We don't have to know how much that angle is. We can find cosine of that angle. So cosine we're going to use SOHCAHTOA. So I'm going to write it up top. So cosine, we're going to use the A and the H. So this is adjacent over hypotenuse. So to find cosine of your angle, you need the adjacent side. Well, my adjacent side to my angle here is this one. And the opposite is 5, and the hypotenuse is 13 for this angle here. So some of you might remember that there is a 5, 12, 13. It's one of the special triangles. If not, the way you find 12 is using Pythagorean theorem, because we know for right triangles, a squared plus b squared equals c squared. So I know that 5 squared plus my adjacent side squared is 13 squared. So my adjacent side squared is 13 squared minus 5 squared, which brings you down to the adjacent side equaling 12. Okay, just plug that into the calculator. So to find cosine of the angle theta, cosine is the adjacent over the hypotenuse, so that is just 12 over 13. Okay, cosecant, that is the hypotenuse over the opposite, because remember cosecant is related to sine, so if sine is opposite over hypotenuse and cosecant is the reciprocal, it's hypotenuse over opposite now. Hypotenuse is 13, the opposite is 5, so it's 13 over 5. And finally tangent. Tangent is TOA, so it's opposite over adjacent. And the opposite is 5, and the adjacent is 12. And all I ask is that you keep these in reduced fraction form. I do want improper fractions, and these are all reduced, so we are good. Okay, so here we're going to use SOHCAHTOA to solve for x. So we're going to use SOHCAHTOA. So we're going to look. We have an angle. We don't have theta. We're told what theta is, and we want to find x. So for our angle, for a theta, we have the adjacent side, right? This side would be opposite. We don't know what that is, but we know what's adjacent to it, and we know the hypotenuse. So using SOHCAHTOA, which trig function uses the adjacent and the hypotenuse? Well, that would be cosine, because cosine of some angle theta is the adjacent over the hypotenuse. So that uses SOHCAHTOA. So my angle, that's my theta, 60 degrees. So I'm going to plug that in. So cosine of 60 degrees. Theta is always your angle. And cosine is adjacent, which is called x, over hypotenuse, which is called 16 for this problem. And we're going to solve for x. So to solve for x, I'm going to multiply both sides of the equation by 16. So they cancel. And I have x is 16 cosine of 60 degrees. Well, cosine of 60 degrees, that was on the unit circle. Okay, so using the unit circle, you know what cosine of 60 degrees is, because we had that in the last lesson. So if I don't have a unit circle here, but if here's part of the circle, and here's my 60 degree line, right? So this was 60 degrees, my pi over 3 angle. And if I had my triangle, remember it went over 1/2 and up root 3 over 2. So it had the coordinate 1/2 root 3 over 2. So cosine would be the x coordinate here over the unit 1. So it would be 1/2. So x is 16 times 1/2, because cosine of 60 degrees is 1/2. So my x is 8. Okay, so that's how we solve for x using SOHCAHTOA. So SOHCAHTOA will work when we have right triangles. So if we're given a right triangle, we can use SOHCAHTOA. Because we had a special angle 60 in here, we could also use the unit circle. Okay, and using the unit circle is always equivalent to using these special triangles from trigonometry, from geometry. Okay, so the next example says sketch a right triangle. So sketch a right triangle corresponding to the trig function. So when we're asked to do something with a right triangle and a trig function, that usually means we're going to be doing something with SOHCAHTOA. I would say one of the confusing parts in trigonometry in this section is determining, do we use the unit circle for this, or do we use the right triangle? Okay, so if we draw a right triangle, we do SOHCAHTOA. Those go hand in hand, drawing right triangles and using SOHCAHTOA. Seeing angle measures of 60 degrees, 30 degrees, or a multiple of those, we're going to do straight up from the unit circle. Okay, so here it tells us that theta is between 0 and pi over 2. Remember, pi over 2 is 90 degrees. Okay, so our angle is between 0 and 90 degrees, which means we are going to be in quadrant 1. So I'm always going to draw my triangles in quadrant 1, or whichever quadrant we're going to be given the information. So drawing this in quadrant 1, I have some angle theta. And remember, your angles always come out from the positive x-axis. So cosine, using SOHCAHTOA, is adjacent over hypotenuse. So if this is my angle theta, my adjacent side is 3 and my hypotenuse is 8. Of course, it could have been a scaled triangle, but it would be similar triangles where they're just going to reduce the fractions to 3/8. Okay. So we're going to have 3 and 8. And we're going to find cotangent. So cotangent is the reciprocal of tangent. Tangent is opposite over adjacent. So cotangent is adjacent over opposite. So in order to find cotangent of this angle theta, I have the adjacent, I need the opposite. So I'm going to use Pythagorean theorem. So I know that a squared plus the opposite squared, my b squared, equals c squared, my hypotenuse, 8 squared. So opposite squared is 8 squared minus 3 squared, or 64 minus 9, which is 55. So opposite is square root of 55. Okay, so I have that side. So my cotangent of the angle, which I want to find, I used that given and I used that given. And now I'm using SOHCAHTOA, is the adjacent side over the opposite side, square root 55. Now this is a reduced fraction, but it's not rationalized, and we always have to rationalize our answers. So we are going to go ahead and rationalize by multiplying by root 55 over root 55 to get our final answer, which is 3 root 55 over 55. And if the 3 and the 55 could be reduced, then you would at this time, but they can't. Okay, so that is that problem, and we're going to go ahead and move on to the last example. It says use the given function values and the trig identity to find the indicated trig functions. So I know that sine of 30 is 1/2 and tangent of 30 is root 3 over 3, and those are both on the unit circle. Okay, so what we can do is we can look at the unit circle. So if we want to find secant of 30, we know that on the unit circle, secant of 30 is your r over x, and then when we want to find cotangent, cotangent is x over y. So we can use those things. And we're looking at, for now, 30 degrees. Okay, so I'm going to draw a portion of the unit circle, and I'll have my 30-degree angle, which would be here, and then I'll have my 60-degree angle here. So for my 30-degree angle, I went over root 3 over 2 and up 1/2. So if you have your unit circle handy, these numbers are on it, and tangent goes over 1/2 and up root 3 over 2 to get to 60 degrees. So I do have those. So secant of 30 is my r over x. So here's my 30-degree angle on the unit circle, and my x is root 3 over 2. So r on the unit circle, my r is 1. So for part A, it's 1 over x, which is root 3 over 2. And when you have something divided by a fraction, you have to multiply by the reciprocal. So it's 2 over root 3. And then you have to rationalize, and you get 2 root 3 over 3 for your answer. And then for cotangent of 60 degrees, so here's my 60 degrees, cotangent is your x over y on the unit circle. My x is 1/2. My y is root 3 over 2. When you divide by fractions, you multiply by the reciprocal. So I'm going to take the reciprocal of the denominator. My 2's cancel, so I have 1 over root 3, which of course needs to be rationalized. And I get root 3 over 3 as my answer. Okay, so we could also use the special triangles to solve all of these, which I can show you in class, but this was using the unit circle. So that is all of the lecture for the SOHCAHTOA section, and I hope you have a good night.